Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to literally go beyond CPCTC. We're going to go beyond corresponding parts. Congruent triangles are congruent. And before we could do that, I'm going to have to teach you two little things that are very useful and also very important in geometry. And the first one is a median. What is a median of a triangle? Well, a median is a line segment, or ray that extends from any vertex of the triangle to the midpoint of its opposite side. Think about that. So it extends from any vertex to the midpoint of its opposite side. So in other words, a median divides into two congruent segments, okay, or bisects the side to which it is drawn. Each triangle could potentially have three medians, as shown below. The first triangle, I'm just showing you one median here, okay, and it's going from this vertex, and it literally is the median because it bisects, bless you, the opposite side of that angle. And then the figure to the right, you can see very clearly that our red median, okay, bisects its opposite side. The green median bisects the opposite side of that vertex. And the blue median bisects the opposite side of that particular vertex. So this is going to come back to haunt us a little bit later in the course, but when it does, you'll already know what's going on. Okay? Another thing we need to learn and understand today is called an altitude. And an altitude of a triangle is a line segment, or ray that extends again from any vertex of the triangle, but this time to create perpendicular angles, bless you, perpendicular angles with its opposite side. So medians and altitudes, okay, are working with the opposite side from the vertex that the median or altitude was generated. An altitude creates, since it's perpendicular, 90-degree angles with the side to which it is drawn. And just like a median, each triangle can potentially have three altitudes. And the location of an altitude can vary as shown below. You can have an altitude on the triangle, okay? So as you can see very clearly here, here's my triangle, and it's actually on the triangle. It's on the edge of the triangle. You guys know that's a right triangle. It can be inside of the triangle. If you can see, it's different than on the triangle, because inside the triangle, it's literally inside. It's not at any of the vertices of the triangle. And you can also have an altitude, gentlemen, on the outside of a triangle. In this particular case, if you notice, this is my triangle right here, but I created the altitude out here. It's outside of the triangle, okay? But what's really important to know is that the altitude creates a 90-degree angle. It is perpendicular to the side opposite of the vertex. And just like the median, we can have three altitudes. If you notice, this is not cutting the opposite sides in half at all. It's simply creating 90-degree angles. So my green altitude, okay, does not necessarily bisect the opposite side, but it sure as heck fire does create a 90. The blue altitude creates a 90 with its opposite side. This red altitude creates a 90 with its opposite side. Does that make sense, gentlemen? So medians, they come from any vertex and they cut the opposite side in half. An altitude comes from any vertex and it creates a perpendicular angle with its opposite side. Sometimes one must be able to draw a line or array or segment which did not originally exist in the given figure or diagram. We saw this and talked about this. I gave you a little preview about this when we were talking about radii of a circle. Okay? Such lines are known as auxiliary lines. The postulate. 2 points determine a line, ray, or segment. As long as you have 2 points, you can draw a line, a ray, or a segment. Literally, guys. Literally. Okay? Very, very simple. Using the above postulate allows one to draw auxiliary lines which can be formed by connecting 2 points in a figure or diagram. So for example, let's say I have a little circle here, okay? And I have the center right here, which doesn't look like the center, but let's say it's center A. That's my point A, that's the center. And I already have this segment right here. I can literally, I'll go in green so you know it's different. I can literally go up to any point on the circle and draw another segment. And of course that will be a radii as well. And then now you know that this is congruent to that because all radii of the same circle are congruent. But that is super powerful. It's also very powerful on the SAT. Sometimes that's a technique you need to use in order to solve a problem quickly and efficiently. Okay, so as long as you have 2 points, you can connect them to create a line, segment, or ray. Yes, sir? Okay, the question was, does this postulate coincide with all radii of a circle are congruent? Yes, in a way, because you know that there are an infinite number of points that create this circle here, right? So I can connect these infinite number of points to the center point to create yet another radii. So yes, they're kind of, it's good to know both of them. They go hand in hand. Because if you don't know this theorem, you can't really just say, oh, I'm going to draw this radius right here. But now you can draw a radius from the center point to any point along the circumference of a circle. Well, we're gonna see how this is used in proofs. If I draw a line because I connected 2 dots, you're gonna say auxiliary line. That's your no. Thank you. It's a great question, son. Does that make sense, my brothers? I'll take that as a yes. Okay. All right. Let us continue then. Good news. That's it. That's all we needed to learn for today. Now, the fun part. How do we apply it? Okay. I have, in this particular case, given AB is congruent to AC, BD is congruent to CD. I want to prove that triangle ABD, angle, not triangle, angle ABD is congruent to angle ACD. All right. Well, let's check this out. And actually, you know what I'm going to do? Give me 1 second. because I've been thinking about how we do proofs, and it's kind of hard for me to toggle back and forth, and it's kind of hard for you guys to see the correlation. So what I'm going to try to do from now on is as follows. Let's go ahead and clone this guy and make it a lot smaller, but I'm going to actually put him down here so you could actually see that. Okay? Alrighty, so let's get to it. Okay, so now this should actually be able to help us out a lot more. Actually, this is a great idea. Okay, so first things first, AB, of course, is congruent to AC, and of course, that is given. And you know me, guys. I know I'm a broken record, but I like to label. You have to. So AB is congruent to AC. Second given was BD is congruent to CD. So BD is congruent to CD, given as well. So BD is congruent to CD, that's given as well. Okay? Now, from here, this is going to be kind of difficult to prove that angle ABD is congruent to ACD. Can anyone think of something that we can do to, I'm going to give you a hint, to form a couple new triangles here? Yes, sir? I'm so proud of you. So proud of you. Guys, let's use auxiliary lines. Can't I draw a segment from A to D? All right? Well, we have to state that we did that. So you literally say, draw segment AD. Why? Auxiliary lines. You don't have to put definition of auxiliary lines or 2 points that determine a line. But you know me, I like to show you everything so that you can really understand it. You can just put auxiliary lines. Yes, sir, my brother. No, you wouldn't draw the line past angle D, because in that particular case, it wouldn't really benefit us for us to go all the way down here. I mean, you could. I guess it's not going to hurt you. But actually, no, wait a second. I'm wrong. That's actually an illegal action. Is there a point down here that I'm connecting? Do you see what I'm saying, my man? You have to connect it to 2 points. So actually, that's a great question. And I'm glad I made a mistake, because that's how we learn. You have to connect it to 2 points. And we're connecting point A and point D. Now that we created AD, guys, my boy also followed up with, now AD is congruent to AD because of the reflexive property. Bless you. So now I can do little 3 tick marks here. And now what do I know about triangle ADB and triangle ADC, gentlemen? They are congruent because of side, side, side. Fantastic. And now, how can I prove that angle, and I'll do it in purple to show you what we're trying to prove here. How can I prove that angle ABCD is congruent to angle ACD? Yes, sir. That's exactly 100% accurate. CPCTC, and that's the power of auxiliary lines. You got to be honest, that's pretty cool, isn't it? Yeah. This is for enjoyment here. Okay. Any questions on this proof, my brothers? All right, let's continue then. And again, let me do the same thing that I did here. Let's go ahead and get this guy over here. I see people already figuring it out. I'm proud of you. Good job. Okay. So, let's look at our givens right quick. I know that AD is congruent to AC. That's given. So, I know that AD is congruent to AC. And I know that angle ADB is congruent to angle CDB. So that's a given as well. Yes, sir? Come again? Okay. Hold on. Give me 1 second. As always, my students have my back. Thank you so much. That is a little tiny typo, but it makes a huge difference. And I thank you and I apologize. It's AD is congruent to DC. Thank you so much and I apologize. Thank you. You guys always got my back. Thank you. Okay, sorry about that. My bad, big time. Okay, so now we have AD is congruent to DC correctly now. Angle ADB is congruent to angle CDB. That's correct. Now what do I got, guys? Yes, sir, my brother. Not angle DB, but no worries, bro. Even I make mistakes. Excellent. DB is congruent to DB because of reflexive, so that's absolutely accurate. And then now what can I prove immediately right off the bat? Okay, what triangles because of side angle side? Beautiful, son. Triangle ADB and triangle ADC are congruent because of side angle side. Now, I'm trying to prove, guys, that DB is the median. And remember what we had stated. If DB is the median, what does that mean? What does it do to segment AC? It would bisect them, right? Right, guys? Okay, so keep that in mind. So what are we going to prove now that we know that triangle ADB is congruent to ADC? Phenomenal, son. We're going to prove now that AB is congruent to BC. And why? How do we prove that? CPCTC, that's exactly correct. And now that we know that AB is congruent to BC, how can I prove that DB is in fact the median of AC? Isn't that just no, not auxiliary, the definition of a median? Because doesn't a median, I'm sorry? No, how is it an angle bisector? I'm not trying to be sarcastic. No, it's not an angle bisector, it's a segment bisector. It's not a segment bisector though. It's a median. Why is it a median? Because it DB generated from a vertex and it bisects the opposite side. Thank you for that clarification, my man. Thank you so much. Does that make sense, my brothers? All right. Let's move on. We got quite a few more proofs left. Okay, we got 3 more left. May I continue, boys? All right, my brothers. Okay, next. Let me also do the same thing. I kind of like the triangle there with the proof. It makes it a little bit easier to understand. Yeah, we got some good proofs coming up now. They're good stuff. All right, let me clone this guy as well. And let me shorten it up a little bit. Okay. All right. Let's see what we got here now. CD and BE are altitudes of triangle ABC. AD is congruent to AE, and we want to prove that DB is congruent to EC. All right. So let's see what we got here, guys. Of course, number 1, CD and BE are altitudes of ABC. So if CD and BE are altitudes of ABC, if you remember what an altitude does, it creates 90s, right? Creates 90s, right? So we're going to have to express that. We're going to have to now say that And where did my A go? Sorry. I lost my A when I was cloning it. My A is up here. Okay? So I'm going to say now that ADC, because there's two 90s that are created here, ADC and AEB are right angles. Why did I choose those? Well, if you think about it, they're talking about in the next given AD and AE, correct? Let me make this a little prettier. Okay, so I've got to make this angle the 90 and that angle the 90 because they're talking about this triangle and this triangle. You feel me there, guys? You promise? No, we do. No, the reason is not assumed by diagram. The reason is definition of an altitude. Thank you very much, Phil. Thank you for caring and trying. Awesome. But it's definition of an altitude because they told us that they're altitudes, and altitudes form right angles. And now that we know that those are right angles, guys, what do we know about right angles? That they are congruent. Okay, good. We're going to get to that in a second. But next, first we're going to talk about, angle ADC and AEB are congruent because right angles are congruent. Okay? We don't have to say that they're 90. If you wanted to, you could, but you'd be just, doing an extra step for nothing. Because already an altitude, bless you, proved that you're creating a right angle. So now you know that right angles are congruent. So ADC and angle AEB are congruent because right angles are congruent. Now, what can you tell me about angle A here, guys? This angle A. Look at the blue triangle angle there and look at the red triangle angle. What do we know about that angle A? Is it shared by both that blue and red angle? So what happens if it's shared? They're going to be congruent by reflexive. So now angle BAE is congruent to angle CAD because of reflexive property. If it helps you, let me go ahead and do this for you guys. Let's go ahead and isolate this. Let me go ahead and do this. So this is a right angle. And let's go here like this. Sometimes separating it really helps out. So this is B. This is my A. And this is my E. And then this is my A. Come on. And then this is my C. And this is my D. You guys feel me? So I know that A is congruent to A. So angle BAE is congruent to CAD. Hopefully that helps out a lot. Okay? Next, I know that AD is congruent to AE because that's given. So let's go ahead and mark that figure up as well. So AE is congruent to AD because of given. Now, looking at the separated triangles that I in a very ugly fashion created, but nevertheless created, what do we know about triangle AEB and triangle ADC? They're congruent. Why, my brother? That's exactly correct. So triangle ADC is congruent to triangle AEB because of angle, side, angle. Excellent. Excellent. All right. So now that we know that those two are congruent, we're going to use multiple visuals here. I'm trying to prove that DB is congruent to EC, right? So what do I need to say first before I can make that final proof? I know that triangle ADC is congruent to triangle AEB. So if that's the case, what do I have to know about side AB and side AC, or rather, yeah, side AB and side AC, they're congruent. Why? CPCTC. So now, look at everything together. I know this is a confusing proof. If AB is congruent to AC, but we know that AE and AD are also congruent, how can I prove that DB is congruent to DC, to EC? Subtraction property, you guys make me so proud. Phenomenal. That's a proof. That's a real proof right there, guys. Does that make sense, though? And you saw I had to use multiple visuals there. Yes, sir. Usually the altitudes will be given. Yes, sir. Yes, sir. Okay. All right, let's continue. Two more. Okay. Yeah, this is definitely a very long proof. It's going to be a good one. And our announcements are going to come up in a second. When they do, I will pause, and then we'll finish up, okay? But let me go ahead and do the same thing here. All right. We definitely want to see the figure here for this monster proof. Okay. So, my given is that G is the midpoint of FH. That's given. So if G is the midpoint of FH, what do we absolutely know immediately? Yes, sir. Very good. Very awesome. Very awesome. FG is congruent to HG because definition of midpoint. So this guy's congruent to that guy. I'm sorry. We're going to draw a line soon. But first, let's look at our other given. Thank you, though. I'm proud of you. EF is congruent to EH. That is also a given. So EH is congruent to EF because of given. And now you took the words out of my mouth. Draw EG. I'm very proud of you, son. You draw EG because auxiliary lines. Definition of auxiliary lines. And let's hold right here and pause for announcements. We'll be right back. Okay, thank you for that, guys. All right, so we have definition of auxiliary lines, EG. So now I know that EG is congruent to EG because of the reflexive property. Okay? Once we know that, we can easily prove that triangle EFG is congruent to triangle EHG because it's side, side, side. Now remember what we're trying to prove, guys. We're trying to prove that angle 1 is congruent to angle 2. So what I'm going to state is the obvious. Angle EHG is congruent to angle EFG because of CPCTC. And then I kind of jumped the gun here accidentally, sorry. Then angle 1 is supplementary to EHG because definition of supplementary angles. Angle 2 is supplementary to EFG because definition of supplementary angles. And then we can prove angle 1 is congruent to angle 2 because supplements of congruent angles are congruent. Yes, sir. No, we don't have to define HGF as a straight angle anymore. We can assume that. Okay? Does that make sense, guys? It's a good proof. It's a good proof. As you can see, we're starting to really blend in all of the chapters now, like I promised. Okay? Now we got one last proof, and it's also a fun one. All right? But don't worry, this is great training for tonight's homework. All right? So let's just move on. So I know you guys want to get out of here. Okay. Let me just do the same thing. This helps, right? When I put it. Okay. Well, it may not help everyone, but I think it helps because you get to see everything in action. Okay. So, my givens are, first given is that t is congruent to y, and of course that's given. You know me, I'm going to start labeling like a madman. Next, my next given is that angle SVZ is congruent to angle SXZ. So that means this guy is congruent to this guy. Okay? I'm trying to prove that SZ, segment SZ, is a median to TY. So I know that eventually I'm going to have to prove that TZ is congruent to ZY. Well, this is pretty easy to prove if you really think about this. I know just by looking here, isn't angle SVZ supplementary to angle TVZ? Definition of supplementary angles. And isn't angle SXZ supplementary to YXZ? Supplementary angles. Why did I use that? Because now I can prove that angle TVZ, which is this guy right here, is congruent to angle YXZ. Okay? That makes sense? Okay, no, reflexive doesn't play a part here, sir. This is not reflexive. This is TVZ is congruent to YXZ because supplementary congruent angles are congruent. But then they tell us that TV is congruent to YX. So that means this guy is congruent to this guy. So now what can I tell about triangle TVZ and triangle YXZ? Look at the markings, guys. They are congruent. Very good. Why? Angle, side angle. Spectacular. Now, oh, sorry, I jumped the gun here. TZ is congruent to ZY because of CPCTC. And now I can prove that SZ is the median to TY because definition of a median. Does that make sense, my brothers? Awesome. Thank you so very much. Hope you learned a lot and have a wonderful day.